Hello everybody and welcome to exercise 5 on page 60 of the workbook. Let's take a minute to read this problem together. So they're giving us a group of order 8 and they'd like us to show that G must contain an element of order 2. So basically saying here that you take any group of order 8, no matter what it might look like, abelian, non-abelian, cyclic, not cyclic, we'd like to prove that there's got to be at least one element of order 2 somewhere in that group. All right, so here's how we might start this problem. We're going to choose just any element in the group that's not the identity. Okay, and the question we might ask to get us started here is, what are the possible orders of that element that we just picked? Well, it can't have order 1 because it's not the identity. What are the other possible orders? Okay, well, our group has order 8, so we know by a corollary to Lagrange's theorem that the order of this G has to be a divisor of 8 that's not equal to 1. So what are the possibilities? Well, we've got divisors of 2, 4, or 8. Those are the divisors that aren't equal to 1. Okay, and so let's just make a list of those. The order of G is either 2, 4, or 8. Okay, and that's by one of the Lagrange's theorem corollaries. Okay. So we're going to kind of look at these cases one at a time. Okay. The first case is the order of G being 2. Okay, well, if the order of G is 2, we're done because we wanted to prove that G contains an element of order 2. Okay, so that's kind of a trivial case. More interesting are the other two cases. What if that G that we chose has order 4? Okay, well, if the order of G is 4, then that means that if we take G and raise it to the 4th power, we have to get the identity. Okay, but notice that if G to the 4th is equal to the identity, then G squared squared is equal to the identity. Okay, and so it's interesting what we've done here. We've taken the group element G squared, raised it to the 2nd power, and gotten the identity. That actually tells us that the element G squared has order 2. Okay, there's the element of order 2 that we were looking for. Okay, now before we proceed to case 3, I have to make a little bit of a confession here. Okay, I left out a little detail in this argument. I kind of jumped immediately to the statement that G squared and G has order 2. You might remember, if you look carefully back at theorems from chapter 3 and chapter 4, it's not quite that simple. Okay, raising G squared to the 2nd power and getting the identity, all that really guarantees us is that the order of G squared is a divisor of 2. Okay, so I'm kind of leaving it to you, the reader / listener, to figure out why it is we can really with confidence say that the order of G squared is 2 and not 1. Okay, I'm going to let you think about that. Okay, and move on to case 3 here. Okay, so what if the order of G is 8? That was our last possibility. Okay, well, that would mean that G to the 8th is the identity, and G to the 8th can be written as G to the 4th squared. Okay, so we have created an element in our group, G to the 4th, that we can square and get the identity, and so G to the 4th is an element of order 2. Okay, and again, I'm making a little bit of a leap there, the same way that I did in case 2. I'm asking you to think about how we can really say that the order of that G to the 4th is 2 and not 1. Okay, and if you look at our cases, case 1, case 2, and case 3, we were able to find an element of order 2 in every single one of those, and so we have proven that every group of order 8 has an element of order 2.